Welcome to topic 6 of CP1. In this topic, we're going to talk about stacks. So a stack is an abstract data type. It has two main operators, push and pop. So it may support some additional operations and functions, for example, getting the size of the stack, how many elements are already in there. But the main ones are push and pop. And stack has the property of last in, first out. That's different from queue, which is first in, first out. So when you pop things, the order of the things that are popped is reverse order of the ones that you push in. So let's look at the example. Suppose we do push 1, push 2, push 3. Then the next pop will give us 3. Let's say we also do push 4. Then the next pop after that will be give us 4. So the element 1, where we push first, will come out last. So only after we keep popping until everything else is gone, then the 1 will be popped next. So understanding how to use stack is extremely important in programming. It's a very fundamental data structure. It's the concept of stack is actually implicitly used in almost any programming language. So for example, the function call is implemented using stack because when a function call itself, either directly or indirectly, you have multiple versions of a function that are running at the same time. So if the function has variables, then you need multiple copies of them. So this is implemented using stack, and so for those of you who are interested in security, then program bugs that can cause the stack to overflow can overwrite content on the stack to gain control of the execution. So this is a common software attack known as Stack Overflow, and also the Stack Overflow is the name of a popular website where programmers ask questions and get answers. Okay, so in Java there is a stack class which is implemented using a vector class, which is a array list, but with a synchronization added, so that if there are multiple threads running, they call addition and removal on the same vector. These will be synchronized so that they will not cause race condition to cause the data structure ended in an inconsistent state. However, the way synchronization is done in vector and stack is at a very low level, so at the individual function call level. In general, when you use this vector and stack data structure in a particular application, you will basically wrap this method around to support your operation. It's oftentimes what you need is to do synchronization at the higher level instead of at this underlying data structure level. So for that reason, these stack and vector are considered obsolete. So they were added, I think, in the very first version of Java, but now they are considered obsolete because typically when you use them for multi-threaded application, you will add additional layer on synchronization on top of it. So then the synchronization in here will just slow things down without providing actual benefit. So to understand the synchronization, I think this first covered in 252 and also later probably in OS and the database course. So yeah, but they were there. So the stack and vector were there. We cannot use the name now to be backward compatible. So currently it's recommended to use ArrayDeque instead of stack. So this ArrayDeque is a newer data structure introduced in Java library. So Deque stands for double-ended queue. So it's essentially a linear array, but it stores efficient adding and removal element at the two ends. So you can add at the beginning and add at the end, remove at the beginning and remove at the end. All of these are constant time operations. If you just use array list, adding and removal at the beginning will be linear time operations, because after you delete element 0, you need to shift all the element forward. So and if you don't know how to implement Deque using array list as underlying data structure, then that's something you should definitely look up. That's a very basic concept of data structure. Typically, they're implemented by using array list with two pointers pointing to the beginning and end of valid element. And when it gets too big, then you need to allocate the bigger array and make a copy. So the amortized cost of that will be a constant time operation for each add removal. And when we are using ArrayDeque instead of stack, ArrayDeque also provides functionality of a queue, so you can add things and remove things at both beginning and the end. So knowing the API of this one class allow you to also implement a queue, and also implement things kind of neither stack nor queue when you need the add and remove at both beginning and the end. So for that reason, it's good, because you learn one thing and you can use it in many situations. So let's see. So the main interface is you can add element at the beginning, add first, and you can also remove first. You can get first, so extract the element without removing it. And similarly, you can add last, remove last, and get last. And these methods, they will throw exception when the methods fail. And different methods fail for different reasons. So add will fail when the Deque is fixed size and full. So when you create a Deque, you can, well, I guess I don't think ArrayDeque will be full. ArrayDeque has a fixed size, so you can, this shouldn't fail except when you run out of memory. And remove and get will fail when the Deque is empty. If it doesn't contain anything, then remove and this will fail. And I think there's also a version like pull first, POIL, and they will have different failure behavior. So I think when you pull first, it probably return a null when it's empty. I'm actually not totally sure, but so you should look those up if you want to rely on those. So that's the Java ArrayDeque. So stop here.